So let me continue this one, right? Yeah, so let's talk about vector multiplication. Last time we talked about scalar multiplication here. So here you multiply a vector by a scalar. When you multiply a vector by a scalar, then what happens? If the scalar is positive, yeah, can you mute your microphone? What's that? All right. So let me talk about this. Then I will finish. Otherwise, yeah. So last time, yeah. So earlier we talked about scalar multiplication, right? So here, so if you have a vector v, then I multiply this vector by a scalar. Now we are going to multiply two vectors, right? We are going to multiply two vectors, all right? So yeah, this is called scalar product or dot product. Yeah, what's up? Yeah. Yeah, so this is called scalar product or dot product, right? I think you have learned this one in your A levels. So if so, now, yeah, now we have two vectors a, b. Now we are going to multiply these two, or we are going to operate or multiply these two vectors, right? So, all right. So the resultant one, when you multiply this one, when you take the dot product of these two vectors, then you get a scalar. That's why we call scalar product here, right? So when you consider dot product, when you take the dot product of two vectors, then the resultant one is a scalar. This is not a vector, right? So dot product of A and B is given by this one. Yeah, we write that down. Yeah, A dot B is magnitude of A, magnitude of B, cos theta. If you know the angle between A and B, right? If you know the angle between A and B, right, then dot product of A and B is magnitude of A, magnitude of B, cos of theta, right? So this is a scale, right? So this gives you a real number, right? This is called dot product or scalar product, right? So if the dot product of if A and B are non-zero vectors, that means magnitude is not equal to 0. But if the dot product is 0 means, so that means cos of theta is equal to 0. That means theta is equal to pi over 2. Right? Here theta is in between. Since theta is in between minus pi plus pi, right? Here, which angle should we substitute for theta with? Now let's assume theta is the angle between A and B, right? Theta is the angle between A and B. Let's assume A is this angle is known, right? And then we can define dot product with this angle, right? Magnitude of A times magnitude of B times cos theta. If you don't know the angle, so definitely you have to know the angle between A and B if you want to use this, right? Or if you don't know the angle and if you know the coordinates, let's say A is AX I plus BX AYJ plus AZK, and similarly you can define B, then dot product of A and B is sum of A. Next time I will generate a blank sheet. Yeah, there's a couple of blank sheets. A dot B is same with AX BX plus AY BY plus AZ BZ. So you can use either definition, right? So if you know, if let's say if you know the angle between A and B, and then you can define the dot product, right? And let's say if you know the coordinates like this, x coordinate, y coordinate, and z coordinate, right? Then you can use this definition, right? So basically, so this is the definition of dot product, right? So the important thing is when you take the dot product of two vectors, you are not getting a vector. This quantity is a scalar. This is a scalar. That means this is a real number, right? So dot product is not a vector value, it is a scalar, right? So if A and B are perpendicular, then what happened to this angle? Then this angle would be pi over 2, then cos pi over 2 is 0, and dot product would be 0, right? And if you take the dot product with itself, then angle would be 0, cos of 0 is 1, then dot product of A and itself is the magnitude of A square. Okay. All right. I think you have done these things in your A levels. And dot product has this property here. Here, look at this. Have you noticed that? So here, so you can swap these two. So you can swap and operate. Here, you can interchange A and B, then you get the same quantity because these are scalars, right? We know that a set of real number, the set of real number has commutative property. So that means you can swap these two. So the product, yeah, follow this property, commutative property. And also you can expand this bracket like this. It has, yeah, distributive property. That means, yeah, brackets or parentheses are not important for the dot product here. Yep, here it is not. No, this is distributive. And but look at this one here. So let's consider three vectors. See, is this true or not? Let me know, is this true or not? Can you write this one? What can you say about this? Is this true or not? Can I write in this way? Here, look at this here. We cannot write in this way. Why? Why? B dot C is not a vector here. B dot C is a scalar. Dot product is defined for two vectors. Here, A and B must be vectors. But here, look at this. B, when you take the dot product of B and C, this gives you a scalar value, not a vector value. Then we cannot talk about dot product. Then, right? So this would be the scalar product. This should be the scalar, but not dot product, right? So this is a different product, and this is a different product. So I will denote this one in this way. I will denote dot product. Yeah. So this is dot product, but this is the scalar product, right? That means, so when you take the dot product with B and C, this gives you a scalar. This scalar is multiplied by, yeah, this vector is multiplied by this scalar, right? So you have to be careful. Yep. So do we always get a scalar when multiply? Or so we haven't defined division of two vectors. We only define here. So far, we have defined only multiplication of two vectors, not division here, right? So this is multiplication of two vectors. So this is called scalar product. So when you take the dot product between A and B, you get a scalar. So it is not a vector, right? Yeah. So it's a vector product. Is vector product. Product. Product associative. No, we can talk about associativity. Why? Here, so because this is undefined, this is not defined, we cannot talk about very good, this property. It doesn't have this property here. Which property? Associative property. This property, we cannot talk about associative property here. This one is this is dot product, and this is B and dot product. So here, because this is a scalar, so we cannot define like this. So this is not defined. The scalar, a dot product does not have this property associated, but it has commutative property and distributive property. Which one here? Distributive property here. as that. Yeah, here. So here, so adding two vectors gives you another vector. This is a vector. Then you take the dot product with the resultant. Yeah, dot product with this one and A. Yeah, all right. This one is defined, but this one is not defined. So therefore, it doesn't have associative property. It is not defined. So you can, so this is wrong. This is wrong. But this is okay. This one is okay. So this is normal multiplication, normal scalar multiplication, B dot C. So this gives you a scalar. Scalar is multiplied by this vector. That is okay. But this is between A and B. So you cannot say, okay, this is dot. No, this is not dot product between two vectors. No, but it is a scalar. It is, this is, yeah, this is vector and this is a scalar. This is a scalar product. Okay. Yeah. Does scalar product always give a scalar value? Scalar product, dot product, yeah, dot product gives you, yeah, dot product always gives you a scalar. This is a real number, that's why. So this is not a vector, this is a real number. All the time, this is a real value. All right. So, okay, let's look at this one here. Here, look at this. Here, this is a number, real number, u dot v. All right, this is a number. Number is multiplied by a vector. That means it is stretching or shrinking. So this could be negative or positive or zero. If this is zero, then this becomes zero vector. If this is non-zero and positive, and that means direction of W does not change. It is shrinking or stretching. If the scale is greater than 1, that means stretching, right? If the scale is less than 1, that means shrinking, W, right? All right, that is okay. This one is not equal to this. So I hope you understand, right? So this is a scalar times this vector, right? Which is not equal to this one. So this is a vector, but this gives you a scalar. So u times a scalar and w times a scalar, which is not equal, right? Did you understand that? Did you see that? So how?
Yes, sir.
All right, thank you. So will someone, yep. Give me a second, someone is asking a question now. So how will dot product of three vectors look like? No, you cannot define dot product for three vectors here. I think you understand that here. Here, so here, look at this here. So this gives you a scalar, not a vector. This is not a vector. This is a scalar, dot product between two. Dot product of two vectors gives you a scalar. So you cannot talk about A dot B dot C. No, this is not dot product, but this is scalar product. This one is a scalar product, right? Different one. So let's write this one. A dot B times C. This is okay. So this multiplication is scalar multiplication, not dot, not dot product, right? This is not dot product because this is a number. This number is multiplied by this vector, right? Did you understand now? Yeah. All right. Okay. Yep. I will give some exercise. So maybe I will upload that tonight or tomorrow. Not tomorrow in the evening. Yeah, tomorrow in the evening. Just complete those exercises, then you can get an idea. Yeah. So yes, that. Yeah. Yeah. So can you understand this one? So this one is not true. So did you understand this? So here, when you multiply, when you take the dot product of u and v, this gives you a scalar. That scalar times w, all right, which is not equal to u, and this is another scalar u. Yeah, this is true, right? You can give an count. Can give a count example. Yep. Can you please explain me that if the angle between A and B is not given, how can we define A dot B?
Sir,
Yep. Yes, go ahead. Yep. If you have any question, yep.
sir, can we write it UV cos theta W?
U, yeah, magnitude of U and magnitude of V cos theta times mean normal multiplication times W. Yeah, that is right. Right? Times W, which is not here, this one magnitude of V times magnitude of W cos another angle. We don't know, right? Another angle beta times U. Those are completely different vectors, right? Did you see that? So this vector along W, this vector is along U. Did you see that? So first one is along W, and because this is the vector and this is a scalar. So this vector along U and this vector along W. Did you see that? Did you understand that? Oh,
Yes.
all right. I will give some exercises then. Yep. So yeah, so you can define if you know dot product here. So for instance here, look at this. Here vectors are given. These are position vectors, right? Okay. A and B are given here. Then so dot product of A and B. This will answer to that question, right? Is equal to product of x coordinates 3 times 2 plus 3 times 2 plus product of y coordinates 1 times 1 plus product of z coordinate 5 times 3, which this is the dot product. So this is the dot product of A and B, and divided by magnitude of A. You can find magnitude. So magnitude is square root of x coordinate squared plus y coordinate squared plus z coordinate squared. Likewise, you can find the magnitude of b. Then here you will get a number. Then take the cosine, arc cosine, yeah, cos inverse of this value. Then you will get the magnitude, the angle between A and B. So if you know the angle, you can use this definition. If you don't know the angle, you can use other definition. I think you know that, right? Other definition is, yep, another one. A dot B summation A. I will say A I B I. Yep. I 1, 2, 3. Or if you have n dimensional vector 1 to n, that means A has n components. A has n components, A1, A2. In A levels, you have 2 components. In A levels, you have 2 coordinates, x and y. Here you have generally n number of coordinates. Let's say A3 dot 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 AN. That is A, similarly B, and that product between A and B is equal to this sum. If you don't know the angle, those are not important. Right, there are 2 definitions for dot product, right? With angle and these coordinates, position vectors. All right. So these are, so 430. So is the vector product and cross product? Yeah, both are the same. So some people say cross product, and some people, yeah, other people say cross vector product. Yep. So work done on body. Yep, these are examples. All right, I will discuss this one too, right? Yeah, maybe tomorrow. Yeah, next time I will discuss this one. Otherwise, yeah. So you haven't learned this one before, so we will discuss this one later. Yep. So far, what did we discuss? Yeah, so far we have this. We understood the distinguish between scalars and vectors. Scalar has a scalar. A scalar has single quantity, but a vector has 2 quantities. Quantities. It has, so this has only magnitude. This has direction and magnitude, right? So you can define a vector like this here. So a collection of, so you can generate infinitely many. So because you look at everyone has the same length or same magnitude and direction, right? So this set of vectors represents a single one. You don't need, that means you can shift this vector to anywhere you want. So in this plane, you can shift this vector to anywhere you want. You can generate infinitely many vectors, but everyone has same length and direction. That's the thing. That's the property that collection has, right? Okay, so if you multiply this vector by -1, then you can change the direction, but magnitude remains the same. And when you add two vectors, you get another vector, and you can use this triangular. You can complete this triangle to find the resultant one, right? So you have, yeah, you have learned these things in levels. And set of vectors has these properties. It has commutative property. So you can, when you someone's, yeah, can you use a calculator? You don't need a calculator for this one. Yeah, you don't need a calculator. Yeah, you are not allowed to use a calculator in exams, right? So just complete these exercises. So then I will prepare some tutorials. I think those are very helpful for your exams. So complete those tutorials. Then you don't need to worry about things. You don't need a calculator, right, to solve vector problems, right? Okay, so yep. Yeah, it has commutative property here. When you add two vectors, the way you add is not important. You can swap these two if you want, but you get the same vector. Or when you add three vectors, yep, the way you add three vectors is not important, right? That means it has this set of vector has associative property, right? And this is the scalar multiply of a vector. That means, so if you multiply by if you multiply this vector by a scalar, if the scalar is positive, then and less than one, let's say less than one, the resultant one would be, the magnitude would be, would change, and the resultant, that resultant one would be less than, the length of resultant one would be less than 2, this original vector, because this scalar is less than 1. If this scalar is bigger than 1, the resultant one would be bigger than this vector. But the direction does not change because it is positive. If it is negative, direction changes, right? And if it is less than -1, it is strange. Awesome. When will you upload recording to maybe, today I will upload that. No, after this class I will. If you, so if this scalar is negative, then direction changes, right? And if it is greater than 1, then it is stretching to other side, to other direction. If it is less than -1, that one is stretching. That vector, the resultant vector is stretching. Right. If the scalar is 0, you get the 0 vector. Right. We cannot define a direction. We can consider it. It has many directions. 0 vector has infinitely many directions, I think. But the magnitude is 0. All right. So so multiplication of vector by scalar. So we have discussed this one, and to talk about position vectors, definitely we have to consider the reference frame. If it is two-dimensional, we can talk about 2D vectors. That means position vector. You can take any point on the plane, then we can define the position vector very easily using this x coordinate and y coordinate, right? Same with 3 dimension or n dimensions, right? All right. And unit vector, it has is a vector. Unit vector is a vector with magnitude equal to 1. So if you are given any vector, you can find a unit vector along that vector, right? Right. So if you talk about coordinate systems, then you have to talk about unit vectors along axes or x or y or z. If you have 3D vector coordinate system, so definitely you have to introduce 3 unit vectors along the axes. If you have two-dimensional coordinate system, definitely you have to take 2 unit vectors along the axis, right? Yep. Yes. Example. Yeah. This is, and this one very important when you. So this is the multiplication of 2 vectors. Earlier scalar multiplication here. Yes, that. Yep, multiplication of a vector by a scalar, but here multiplication of 2 vectors, right? These A and B must be vectors, not scalars, right? Very important. So when you take the dot product of 2 vectors, you all the time get a scalar. This is a scalar, real number. It doesn't have a direction. It doesn't have a direction. It is a quantity, only magnitude only. Yeah, quantity, right? So if you know the angle A and B, if you know the angle between A and B and these A and B, then you can use this definition. If you don't know the angle, then you can use this definition, right? Right? What else? All right. So this dot product, this operation, dot product, this operation has this property, commutative property. That means if you consider the dot product, the way you take the dot product is not that important. You can find A dot B or B dot A. You get the same quantity here. The order is not important for dot product, but the vector product or cross product, it is important. It is important here. For scalar product, it is important. That is important. Scalar product here. It is non-commutative, but this cross product is non-commutative here. It is there's you cannot interchange these A, B, but in dot product you can interchange. You get the same quantity. It has the scale product has a distributive property. That means you can span this bracket and cross product as well. Yeah. Here you can expand this bracket. expand this bracket. Okay, next week we will discuss that. And the other one, yep. Right. So so here, and this one is important. Dot product between u and v, and this gives you a scalar. Scalar times w. That means this is a vector, some vector along w. We don't know the direction, but we don't know this. So here you have w, right? W. So this is a scalar times w. We don't know in this direction, but we don't know this direction or this direction, but that vector along w, either this way or that way, along w, we know that, which is not equal to that, because this is a scalar. This is a scalar multiplied by the vector u. So this is a vector along u. So generally this one is not equal to this one. Generally, yep. Hope you understood. Do you have understood what we have discussed today? Do you have any questions? Yeah, it's time to ask questions. Yep. If you have any questions, so these are notations, I think, here. So px is this distance. Then you can write a relationship between these angles. That's the thing. So this is not a exercise or example. Yep. This, if you denote this x coordinate of this p is px and py is the y coordinate and pz is the z coordinate, right? Then you can write these px, py, pz using these angles. You can write expressions, expression for px, py, pz using these angles. That's the thing. Okay. Yep. Any questions? I will upload these videos to LMS today. Yeah, now after this class. Yep. Any questions? Maybe. Yep. Maybe I will upload some exercise sheet.